Good morning, everyone. This is Srinath from EC section team. Today, I would like to discuss about transforms. First, I would like to content here in this presentation that is what is Fourier transform, spectral to frequency domain, Fourier transform, Fourier forward Fouriers and inverse Fourier transform, properties of Fourier transform, and Fourier transformation in image processing. See first, what is Fourier transform? My dear friends, Fourier transform is nothing but it is named after Joseph Fourier. Is a mathematical transformation employed to transform signals between time domain and frequency domain. It is a tool that breaks a waveform into an alternate representation characterized by sine and cosine. It shows that any waveform can be rewritten as the weighted sum of sinusoidal functions special to frequency domain. Here there are the special to time to frequency domains that are you can see the graphs which is located with f of x, that is endpoints, and uh, here ABCD graphs are there. A is represented there. First graph is represented discrete function of endpoints, its Fourier second graph, its Fourier spectrum. Third is a discrete function with twice the number of non-zero points. Fourth, its Fourier spectrum. And coming to Fourier transform. What is mean by a Fourier transform? Forward Fourier and inverse Fourier transform. Your image A and its Fourier transform A. Then the forward transform goes from the spectral domain to the frequency domain, which is always continuous. That is A equals to f of A. The inverse goes from the frequency domain to the time domain. That is A equals to f of inverse of A. See Fourier transform. My dear friends, Fourier transform means the Fourier transform of f of u of a single variable continuous function f of x is equals to f of u is equals to uh, integration minus infinity to infinity f of x e power minus jt d minus jt dx. The Fourier transform of f of u comma v of double variable continuous function of f of x comma y, f of u comma y, f of u comma v equals to integration minus infinity to infinity, integration minus infinity to infinity. Why we are taking two integrations bit? It is consist the Fourier transform is consist with double variable. That was we are taking the two integrations and two variables. See, then the Fourier transform of discrete function of one variable is f of u equals to 1 by m summation x equals to 0 to m minus 1 f of x e power minus 2t minus jt. The concept of frequency domain follows Euler's formula. E power j naught j theta equals to cos theta plus j sin theta. This is the Euler's formula. Where Fourier transform. What is meant by the Fourier transform? Yes, Fourier transform, where each term of the Fourier transform is composed of the sum of all values of functions f of x. The values of f of x are multiplied by sine and cosine of variable frequencies. Each of the each of the m term of f of u is called the frequency domain of the transform. The domain over which the values of f of u range is approximately called the frequency domain. Hence, we know the frequency component of the transform and frequency domain of the transform. Well, what are the properties of Fourier transform? The properties are linearity, scaling property, time differentiation, convolution property, frequency shift property, time shift property. How these properties are helpful to do while processing the problems. Where linearity, scaling a function scales its transform pair, adding two functions corresponding to adding the two frequency spectrum. If h of x, h of f, then a of h of x is a h of f. If h of x is equals to h of f, g of x is equals to g of f, then h of x plus g of x equals to h of f plus g of f. Means instead of giving small letters, we need to give the capital letter. That is called as the linearity. Scaling property. If f of t is equals to f of w, then f of at is equals to 1 by a f of w by a. This is the property of a scaling property. Then time differentiation. If f of t is approximately f of w, then f of, differentiative with f of t is equals to j omega f of t. With conversion property, if f of t is equals to f of w and f of t equals to f of 2 equals to f of 2w, then f of t into f of t into f t of 2 is equals to f of 1 of omega into f2 of omega, where star is conversion and f1 of t, f2 of t is equals to 1 by 2f, f1 of omega and f2 of omega. Same here, frequency shift property also, time shift property also. Where in frequency shift property, the frequency is directly converted into the shift property, where time shift property is also converted into time to shift property. In other words, a shift in time corresponds to a change in space in the Fourier transform. See, see, frequency shift property. If f of t is f of w, then f of t e power j omega naught t is equals to f of omega naught omega minus omega naught. Time shift property. If f of t is equals to f of omega, then f of t minus t naught is equals to f of omega e power minus j omega t naught. In other words, a shift in time corresponds to a change in the phase of Fourier transform. As we know, Fourier transformation is also one of it behaves the inverse Fourier transform also. See, Fourier transformation in image process. How the Fourier transformation is processed in the image. Used to access the geometric characteristics of this time domain image, Fourier domain decompose the image into its sinusoidal components. In most implementations, Fourier image is shifted in such a way that the f of o comma o represent the center of the image. It is not o comma o, f of 0 comma 0 means the Fourier image where it was shifted means it is shifted on the it will be shifted and it will be represented on the center of the image. It will be only represented on the center of the image, that is f of 0 comma 0. The further away from the center an image point is, the higher is its corresponding frequency. Whenever the center and image point is, it is either explains the higher is its corresponding frequency. When Fourier transformation in image process, the Fourier transform is used in a wide range in image process, where image filtration, image applications, where in image application it is uses as analysis, filtering, reconstruction and compression. Where these are the types which is used the image process of a Fourier transform in wide range in wide range, that is image filtering, image analysis, image filtering, image reconstruction, image compression. See, here there are the references about the Fourier transformations and inverse Fourier transformation. These are the specific types of resources which you can learn and you can compute the knowledge of a Fourier transformations and properties regarding that and information regarding that. That is fundamentals of image processing. Ian T. Young, Jan J. Zerberts, Lucas J. Jan Willett. These are the some websites and the some websites and some books which are references to learn the Fourier transformations and properties and applications. Thank you for thank you for having this session. I would like to say that Fourier transformation is mainly clipped into the